This is a blast freezer built by Akpo Oyegwa Refrigeration Company, AORC. We are powering this blast freezer with 100% free energy from the sun. Watch this video till the end and ensure to share this video. The days of depending on NEPA grid and generators are over. Yes, they are totally over. Let's get into the video and see how this works. Over here is a solar powered blast freezer built by Akpo Oyegwa Refrigeration Company. It is 8 feet in length, 8 feet wide, and 8 feet in height. Like I said, it's a solar powered blast freezer. This is of the highest grade. We used the highest grade of components to construct this blast freezer. Looking at the door, looking at the panels, everything is of the highest grade. I'll be going in to see how well it is running. Over here is the control panel and the condensing unit. Let me move closer and see the temperature within the blast freezer. At the moment, it is minus 9.5 degrees Celsius. At the moment, it is cooling 9.5 degrees Celsius. This is the highest grade of equipment. The condensing unit is with a Bitzer compressor. No unusual noise, no vibrations. Everything is working smoothly. Over here is the cold room, 8 feet in length, 8 feet wide, 8 feet in height. If you want to measure in meters, it is 2.4 meters in length, 2.4 meters wide, and 2.4 meters in height. Now I'm going in. It is extremely cold in here, minus 9 degrees Celsius. This is the evaporating unit. Extremely cold. You can also get in touch with us on our website. You see the price list, our price list. You can go through our price list and decide which price is within your budget. Once you have decided the price that's within your budget, you can then fill in our quotation request form still on our website. We have stored water in this blast freezer, and in a moment it will get frozen. This is just for us to run a test to see how effective this unit is running. So we have stored water in here. The evaporator is running. Now let me go outside and see. Over here we have installed the inverter, the battery, and the rest of the solar power system. This is a petrol generator. Is an outdated system. We are doing away with the generator and we have upgraded to a solar power system. This is the inverter. It is of the highest grade. The brand is SRNE. SRNE, for those who know, SRNE is one of the highest grade of inverters in the market. Over here we have the AGM batteries, very good for high starting current.
The SRNE 12 kilowatts 3-phase hybrid inverter. Hybrid in the sense that we don't have any charge controller mounted on the wall. We are actually maximizing the available space to make sure we have a compact unit. And here we have the 12 kilowatt SRNE. This is a high grade, high quality inverter system. In this inverter we have dual MPPT. 2 MPPT charge controller is connected. On right here we have the solar panel, circuit breaker and surge protector. So on the roof we have 16 units of 355 watts Jinko solar panels. So it's giving us about close to 6,000 watts power of energy, about averagely of 5,600 watts power of energy. So if you look on the screen here, right now it's a very cloudy day, but we are getting approximately 440 volts from the solar panel, and if you scroll, about 2.2 amps. The 440 volts and the 2 amps is actually calculated by the MPPT. It's an intelligent monitoring system. So we are getting 1 kilowatts of energy from the sun right now, which is used to charge the batteries down here. Here we have 4 dry cell battery from Rita. It's 12 volts, 200 amp hour battery. So we have our 250 amps circuit breaker, molded case circuit breaker. So on this part we have the NEPA AC input. Here we get grid supply, but for now there's no grid, so that's why you see this thing is off. But when there's grid, it supplements the power that is used to run the cold room out there, and at the same time charge the battery. So from here we have the inverter output power. We have the voltage per phase. On the first phase we have 230 volts, but right now there's no load on it. We'll still power the equipment later. So down here, I talked about this. We have the 3-phase changeover switch between NEPA and generator and the solar. Right now we are on solar output, and here we have the common bus bar is installed in here. We have the neutral and the earth. Every equipment you see here, the inverter, the cold room, everything is connected at this earthing point. The earthing point is taken out into the ground, so everything here is securely installed. Here, right here, we have 3 cutouts from the NEPA also. This is the 3-phase coming in. Here we can see NEPA and generator. So why we designed this in this way is because in the event where there are no suns for a couple of days, we are not getting enough energy from the sun, we can switch to either NEPA to supply load to the battery and the cold room out there, or we switch to generator. We can switch directly to generator here. So when the generator is also working, it's charging the batteries and at the same time supplying load to the cold room.